All right, so let's go over test number 7. So with question number 1, we were given this graph and we were asked to find two different limits. The first limit, we want to approach -1 from the negative side. So here's x equals -1, and we're asking, as we get close to -1 from this side, what do we approach? And we approach the value of 2. So that limit equals 2. Part B asks for the limit as we get close to 2. Now it doesn't say from the left or the right side. So that means when we approach 2, we have to approach the same thing from both sides. And in this case, as we get close to 2, we approach +1. So there's the answer for part B. Now number 2 asks us to find the sum of this series, 1 plus 2 plus 3, all the way up to 999. Now this is an arithmetic series. Now it may seem a little difficult without a calculator, but here's the idea. The idea of an arithmetic series is that if you take the first number and the last number and add them together, you get a number. In this case, we add them together and get 1,000. If we add the second and second to last number, they also add up to 1,000. And so if we were to continue to do this, all the pairs would add up to 1,000. So to find the sum, what we would do is we would take, instead of each term, what we say is, well, we'll add them up by pairs. And so we have the sum of a pair times the number of pairs. And so we know that there are 1,000 for the sum of the pairs. The question is how many? Well, we start at 1 and then go 2, 3, all the way up to 999. So there's 999 terms. Well, how many pairs would there be? Well, we would take that number and cut it in half. And so that's 499.5. And so we multiply this, and multiplying by 1,000 is simple enough. We just move this decimal point over 3 places. So 4995 and 2 more zeros. So this sum total is 499,500. All right. Now with number 3, this one was probably the most difficult one because we had to fill in that. And there were several right answers. The easy expression to start with is, well, what would it be if it were just n? Well, then we would plug in 0, and 1, and 2, and 3, and 4, and 5. And what that would cause is that would cause a sum to be, well, let's see, 2 and 3 is 5, 1 and 4 is 5, plus 5 makes 15. Well, we want the sum to be 20. What if we chose n plus 1 as our expression? Well, if we plugged in 0, then we would get 1. If we were to plug in 1, we would get 2, and so on. So we would get 1 plus 2 plus 3 plus 4 plus 5 plus 6. Now that would give us a total of 21. Close, but we want it to be 20. Now, one other option is, well, what if we take n and multiply it by 2? Then all of these numbers would double. So 0 plus 2 plus 4 plus 6 plus 8 plus 10. But what would end up happening is we would just get a number that's twice as big as what we got up here. And twice as big as 15 is 30. So that doesn't work. What we need is we need to multiply by a different number. But instead of getting 30, we want 15. And that number would be 4/3. And so we would get 0 plus 4/3 plus 8/3 plus 12/3 plus 16/3 plus 20/3. And what we would end up with when we added all these numerators, we would get 60/3, which is 20. So this is an expression that would work up here for that sigma. Turning to the back side, this is the problem I promised would be on here. Now all of these circles are unit circles, which means all of these radii are 1. And then the question is, well, how can we find the formula for the perimeter for an n-sided polygon? Here we've got a 3, 4, 5, and 6-sided polygon. Well, to do that, like we did in the problem in the book, is we would create right triangles. And what we're interested in is these sides right here, because that is half of one of those sides. So to get that, we know this side, that's the adjacent side, and we want this side, that's the opposite side, which means we're going to be using tangent as our trig ratio. So for an n-sided polygon, this side is going to be 1. Half the side is going to be right here. Now the question is, what is that angle? Well, let's look back up at the triangle. What should this angle be? Well, that should be 60 degrees because there are 3 sides, and normally we would think, well, then that should be 120 if you take 360 and divide by 3. But that's not enough because we're only looking at half a side. So then we have to divide not just by the number of sides, but also by 2 because we're only looking at half a side here. So that means that we're going to take 360, or 2 pi, and divide by 2n, 2 times the number of sides. Now in the book, that's simplified to pi over n. Now if you chose to do this in degrees, that would mean that it would look like this, 360 over 2n, which would be 180 over n. And so the length of this side right here, we're going to use tangent of pi over n, and that's going to equal our side length that we want, we'll call it x, over 1. Now since we're dividing by 1, this is the length of that side that we want. So to find the perimeter, we take the given length, which is tangent of pi over n, and then multiply by 2 times n. We multiply by 2 in order to make it a full side, because remember, this side length is only half of a full side. And then we multiply by n because there are n number of sides. So that is the formula, and that's the explanation for it. Down to number 5. We're given that these two are inverses. Now that means that when we multiply, oops, that should be a multiplication symbol. When we multiply these two matrices, we know what the answer is going to be. We know that the answer will be 1, 0, 0, 1. So we know that if we multiply this first row by this first column, we should get 1. And that's enough information right there to figure out what x is. So if we multiply 1 times x and 3 times negative 1, that should equal this, that number right there. Well, now we just have a very simple linear equation, and so that means x is equal to 4. Using similar logic, we can multiply this row by this column and say that that also equals 1. And so 1 times negative 3 plus 4 times y should also equal 1. So we have negative 3 plus 4y equals 1. So to solve, we'll add the 3 over. So 4y equals 4 and y equals 1. And we're asked to find the value of x plus y. So with x being 4 and y being 1, the quantity x plus y equals 5. On to the calculator portion. Part 6, number 6, part A, we're given a finite geometric series. So the first thing we have to identify is what is it that we are multiplying by? And our common ratio is 3. So now we know our common ratio, but we don't know how many terms here. We know that it ends. And so what we have to do is we have to figure out, all right, 2 is the first term, 6 is the second term, 18 is the third term. What term is this? Well, we would get that by multiplying 2 by 3, n minus 1 number of times. So we set that equal to 39366. And we're going to work on solving for what this number is. So we'll divide that number by 2, 39366 divided by 2. So we have 3 to the n minus 1, and so we have 19683. Now this should be a power of 3. Now this is why we have our calculators, because this is much bigger than any power that we're used to seeing. And so this is equal to 3 to the 9th. So that means n minus 1 equals 9, so n equals 10. So this is the 10th term. So now to find the sum here, we take the first term, 2 minus the first term, 2, times the common ratio, 3, to the 10th power, that's the number of terms, and we divide by 1 minus 3, the common ratio. Now, if you notice, we have a 2 as a factor of both terms on the top, and we end up with a negative 2 on the bottom. And so we can cancel out a negative 2 from all of these. So we have negative 1 plus 3 to the 10th, or 3 to the 10th minus 1. I'm not going to write out the decimal for you, but suffice it to say that that is equal to the finite sum. Now with part B, here, this is an infinite geometric series. And each time we're multiplying by 1/3. And since we're multiplying by 1/3, that means we can find the sum. So we take the first term over 1 minus the common ratio, which is 1/3. So we have 10 over 2/3. So that's 10 times 3 halves, which is 15. And that's the sum for part B of number 6. Moving on to number 7, here we have to find the 12th term, the explicit and recursive forms of the following. Now in part A, if we look at these, we're adding 6 each time. That makes this an arithmetic sequence. So to find the 12th term, we're going to start with 2, and we're going to add 6 11 times. Because again, we don't need to add 6 to get the first term. That one's already there. So when we do that, we get 68. Now using the same form, we can write the explicit form and say that, well, to find the 12th term, we just added 6 11 times. To get the nth term, we start with 2 and add 6 n minus 1 number of times. And there's our explicit form. Now for our recursive, we take the term before it, a sub n minus 1, and say, well, what are we doing? Well, we're doing the same thing. We're adding 6 each time. All right. Now for part B, we're not adding the same number. It's not arithmetic. What we're doing is we're multiplying. We're multiplying by negative 2. And so to find the 12th term here, what we're going to do is we're going to start with 1 and multiply by negative 2 11 times. And so when we take negative 2 and raise it to the 11th power, the thing to remember is that it's going to be negative 2048. Likewise, as in part A, for part B, if I want the explicit form, we just follow the same logic as we used right here. Start with 1, multiply by negative 2, n minus 1 number of times. Now for the recursive, we take the term before it, a sub n minus 1, and say, well, what are we doing? We're multiplying by negative 2. So there is our recursive. Now with number 8, it says to find this limit. And we're finding the limit as x approaches 0. And it says support your answer with an appropriate table. So an appropriate table, what you would have is you would have x getting closer and closer to 0. And I'm only going to put in several numbers. So negative 0.1, negative 0.01, 0.01, and 0.1. Those are the values we want to be plugging in so that we can find what the limit is. Because obviously we can't plug in 0 because we would be dividing by 0. All right, so on my calculator, if I plug in negative 0.1 minus 0.1, I'm going to raise that to the third power and then subtract 8. And then I take all of that and divide by negative 0.1. And I get 11.41. Now, you don't have to use that number, but I'm just choosing that number because that's fairly close to 0. So now, I will also plug in negative 0.01 into this, and we get 11.94. Now, we'll do the same thing for positive 0.01, and we get 12.06. Now, hopefully, you're starting to see that, all right, well, we're getting close to something, but just for clarity, we'll plug in positive 0.1. And we get 12.61. So over here, from this side, it seems to be approaching 12, and from here, it seems to be approaching 12. So that is the limit. As 2 plus x cubed minus 8 over x gets closer and closer to 0, the values approach 12. All right, I hope this helps. If you have any further questions or conversations, anything you want to ask or discuss, please put them in the comments and I will come back and answer that, or someone else in the class is more than welcome to do so as well. Thanks.